In the last episodes, we made our characters patrol around the town using these banners, but having the characters follow a sequence is not very interesting. What we love about NPCs in games and game AI in general is that it's very reactive to the situations that are presented by the world and by the player. And in this video, we're going to see a basic example of this reactivity. We're going to add an energy bar to our characters. This energy will be depleted the more they walk around, and when their energy is completely depleted, they will sleep on the floor to recover. So let's see how we can do this with the help of Behavior Designer Pro. Okay, let's give our villager an energy meter. Let's go to the pawn script. Let's create a private float, energy. Then let's create a public property. And using a property here is important because, as we'll see later, we can bind this property to a variable inside our behavior tree. That way, Behavior Designer will always have access to the value of energy. And this is an important point. Using these systems such as Behavior Designer or Playmaker, it's always a point of frustration for me how disconnected they can be from your own code, which will force you to write your own actions, extend the system, etc. to make it work with your own code. But fortunately, in Behavior Designer Pro, Obsive went in the right direction, and we're going to see some powerful ways that will allow you to interact with your code from the behavior tree without even needing to write custom actions, custom conditions, etc. Okay, let's add some methods down here. Let's create a region. Let's call it energy meter. Let's create a method called update energy consumption. Here we'll get the speed of the agent by using the magnitude of the agent's velocity. Then if that speed is greater than a small threshold, then we'll subtract 10f multiplied by delta time from energy. So here in our energy property, when setting the property, I'm making sure that we don't go below 0 by using mathf max between the value that we provide and 0. Perhaps here we can define this energy consumption rate. Let's go to the top. Let's define a float energy consumption rate. We'll set energy consumption rate to 10, which means that every second we consume 10 points of energy. If energy was equal to 100, this means that it will be completely depleted after 10 seconds, which is great for our testing purposes. But of course, if you're making a game, you'd want energy consumption rate to be lower than this. And let's add serialized field so we can edit these values in the inspector. Okay, so now I'm going to use this update energy consumption in my update method. Then let's add another method. This time let's make it public void restore energy, which will set energy back to 100. We're going to use this method as an action inside of Behavior Designer after the villager has slept for a while. And this is a new addition to Behavior Designer, is the ability to access your code base and use any method as an action. Okay, so let's go back to Behavior Designer. Let's open our behavior tree. So here I'm going to show you something really cool. Let's create a new node. So if you go to actions and all the way down here, we can actually access the whole code base of the project. So we have our namespace here, Tiny Village. We also have access to all the methods in system, in Unity Engine, and all the other third-party assets that you can install. So if you go to Tiny Village, pawn, here we have our restore energy method. We can use it as an action. So let's do it, restore energy. And this is my action. And here it's asking me to set the target. So we're going to set the target to our own object, peasant. Okay, so this is really great. And this opens a wide range of opportunities. You don't have to write custom actions anymore, or at least not as much. So you can just write your code and then use your public API inside of Behavior Designer, which saves an incredible amount of time. Okay, so let's bind our energy property to Behavior Designer. So I'm going to go here and add a new variable. Let's call it energy. It will be of type float. And what we can do here is click on this little arrow, then enable property binding. Here we can choose the target object. Let's set it to our pawn script. And here for the binding, we can choose energy. So here we'll have the list of our public properties. And here it's important that a property has a setter and a getter at the same time. So even if you don't need a setter, you can just define it and leave it empty. So here we're going to choose energy. And once we do this, the value of this variable will always match the value in our script. Okay, so in our behavior tree, we have this branch, which is the patrol. So we can rename this sequence to patrol. Okay, so this is the patrol branch. And by the way, we can also add a comment. Let's say patrolling between banners. If you add a comment, you will see it here, and you can also change the color. So you can right click, set color, and then choose a color for this node. Let's choose a green color. Okay. So this is our patrol branch. Now we need to interrupt this branch in case energy falls below a threshold, and we need to make the character sleep or at least stop for now. For this, let's add a selector. So let's create a node, composites, selector. Let's connect it to our repeater and then to our patrol. Okay, so I'm going to do it and then I'm going to explain later. Here we need to compare the value of energy. So let's go to conditionals, float comparison, and here we're going to compare our energy. So let's click on this dot and let's use our energy variable. So if energy is less than or equal to like a small value, like 0.1, then this conditional will be true. And here we can sleep. So for sleeping, let's just use a wait action. So I'm going to duplicate this one. Let's have the duration set to 3 and let's connect the wait action and the restore energy action. So if energy is close to 0, we're going to wait and then we're going to restore the energy. So here for the selector, so let me explain what a selector is. The selector works exactly like a sequence in that it will execute its children one after the other. However, if one child succeeds, then the selector will stop. So the selector will execute its first child. If that one fails, then it will move on to the next child. And as soon as a child succeeds, then it will stop and succeed itself. So let's read the description. The selector task is similar to an OR operation. It will return success as soon as one of its child tasks returns success. If a child task returns failure, then it will sequentially run the next task. If no child task returns success, then it will return failure. So another way to look at it is it's called a selector because it selects the first child that succeeds. So in our tree, when we start the game, our energy will be at 100. So this conditional will fail, which will make this whole sequence fail. And then the selector will move on to the patrol branch. And in fact here, let's add a repeater because we need this patrol to repeat over time. Okay, let's test this tree. So we're going to run the game and you will see how this branch fails. Okay, so this branch has failed. And as you can see, you have this red X's here, which means that this task has failed. And now we are in the patrol branch. So here you can see that my energy has already reached 0. Let's manually set it to 100. Okay, let's pause the game and let's manually set it to 100 and let's resume. So you'll see how it depletes with time. As the character is walking or running, our behavior tree is stuck here. It will always repeat the patrol branch. What we need to do is be constantly checking for energy. If energy drops below 0, we should interrupt this branch and go back here. So the way to do it is to use interruptions. In Behavior Designer, they're called aborts. But first, let me explain the concept of priority. Since the selector starts with the first child and then moves on, like just for illustration purposes, let's add a third node here. So the selector will start with this one and then move on to the second child and then move on to the third child. So we can say that this child has the highest priority because we start with it first, and then this one has the lowest priority. So priority goes this way from left to right, from the highest priority to the lowest priority. So now we need this node to be able to interrupt this one. So we need this higher priority node to interrupt this lower priority node. So in this sequence inspector, let's go here. And here we can choose the abort type. Let's choose lower priority. And this will create this little icon here on our sequence, which means that this sequence is able to interrupt lower priority nodes. So let's say we have a lot of nodes over here. This sequence is able to interrupt them all. But in order for this interruption to work, we need to actually have a conditional here. So we need a conditional that will always be checked by the behavior tree. And this is the conditional. So when we run the game, okay, let's run the game. You will see that the icon in the stacked conditional is different. Here we have a red X or red cross. And here we have this red X, but we have a circle, which means that this conditional is always being checked. Okay, so it will always be checked. Let's click on our character. So it will always be checked. And once energy reaches 0, you will see that the behavior tree will switch to this branch. Okay, so this is happening. It has switched to the branch and it has called restore energy, which has restored our energy here. It's going to happen again. Okay, it happened again. Okay, so I hope you understand how this example works, because usually this is the structure that you're going to be using over and over and over again, where you have a selector and a bunch of branches and you can interrupt lower priority branches. So interruptions are very important to make your character reactive, and we're going to see a lot more examples in this series. Okay, so let's work on this. Now our character is waiting. Let's close the behavior designer window. Okay, now let's use an animation to visibly show that our characters are sleeping. So let's go to the animator of our characters. Here we have the locomotion state. Let's add another state. So I'm going to right click, create state, empty. Let's click on this new state. Let's rename it to sleep. And here let's add a boolean. Let's call it sleep. And we're going to transition from locomotion to sleep. Let's click on this transition between locomotion and sleep. Let's uncheck has exit time. And for the conditions, we're going to add sleep is true. So if sleep is true, then we'll move to the sleep state. And let's create a transition back to locomotion. And for this transition, let's uncheck has exit time again. And for the conditions, let's add sleep. But this time, we'll only exit when sleep is false. Okay, so let's work on the sleep state. For the motion, let's go to the Toony Tiny People folder. And here we have some animations. So let's go to infantry. Let's go to shield. And let's use this death animation, death P. Let's see it here. Let's drag and drop our character to this window. So this is it. He's sleeping forward and here he's sleeping backward. Let's use this one, death A. Okay, let's go back to the animator. Let's click on this state and let's look for A. Here it is, shield death A. Okay, let's increase its speed, perhaps 1.5. So let's go back to our behavior tree, open. Okay, so here is the sleeping state. So before we wait, let's set the animator's boolean here. So let's right click, create node, action. Then let's go to code base, Unity engine. Then let's go to animator. And here we can find set boolean. Yeah, here it is, set bool. Here we have the name and the value. So let's choose our target. Let's drag and drop our animator here. And let's set the name of the boolean. In our case, it's sleep. And let's set the value to true. We can duplicate this action at the end of the wait. So when we get out of the wait, let's connect this to the sequence and this one as well. So when we get out of the wait, then we should set sleep to false. So this is another example of accessing the code base. Here we're able to use the methods available in the Unity engine without this being a custom action inside of Behavior Designer, which is really great. If you don't like to write code and if you want to use Behavior Designer as a more of a visual scripting tool, then this new change, the code base feature, will help you a lot. So now we should be able to see our characters sleep. Let's set the duration of the sleep to 5 seconds. That way we can see them sleep for longer. Okay, let's do it. Here we have our character. He has 100 energy. Okay. So he's going to move. And now his energy is depleted, so he's sleeping. And after 5 seconds, he gets up again. Let's disable the other characters just so we're fully focused on this one. Let's set the energy consumption rate to 50 just for testing. And let's run the game again. Okay, let's open Behavior Designer here. Let's zoom out. So by the way, if you have a second monitor, then a good use of that is to have this Behavior Designer window open there. Energy is at 0 here. So he's going to interrupt this branch. Okay, it seems to be working. So our character is sleeping. Let's add a small wait here. So after they wake up, let's make them stand for a while by using a small wait. We just want them to stand around a little bit like they've just woken up before moving on with the patrol. So let's make them wait for 1 second. And here we can combine these stacked actions. So let's go to this one. And here let's add our restore energy function or method. And let's set the target to our peasant. Okay, let's remove this one. So thanks to stacked actions, we can have a compact sequence here. All right, Now let's add a particle system. We're going to use Epic Tune FX by Arcanor VFX, which is a great particle system in Unity. Here you can see that I bought it in April 26, 2017. So it was a long time ago. By the way, you can find a link to buy Epic Tune FX in the description. I'm going to apply the URP update here. Let's go to prefabs, then miscellaneous. And here we have the sleep-in particle system. It shows these Z letters going up. So let's go to, I don't like the blue colors. Let's go to color over lifetime. And I'm going to change this blue color to just white. Let's also change the start color. And in color over lifetime, we also have control over the transparency. Yeah, I'm just going to tweak it a little bit. Okay, let's rename the prefab to Sleep FX. I'm going to save this Sleep FX as a prefab and then just remove it from the scene. Then let's go into the peasant prefab. And here let's go to the head transform. So here we have the head container and let's create our prefab here. Let's reset its transform. Let's hit F to focus on it. We need it to be perpendicular to the face. So let's move it up a little bit and let's rotate it around the Y by 90 degrees or minus 90. Let's bring it up a little bit, something like this. Okay, so the letters will be coming out of the face. That's perfect. Okay, so now we're going to disable this effect. What we can do in our behavior tree is have a game object here. So let's add a new variable. Let's call it sleepFX and let's add it as a game object. Let's set it to our sleepFX object. So I'm going to go into the hierarchy, then assign the value of sleepFX to our object here. Now in our stacked actions here, before waiting, we're going to activate our effect. So in the list of actions here, let's add a new action. Let's type set active and here let's choose game object. So it's the first action. And in the target, let's click on this dot and choose our sleepFX value. Then we're going to keep the value unchecked. And after the wait in this action, let's add another set active. And for the target, let's click on this dot and choose our sleepFX again. Then for the value, we'll have it unchecked. And actually in the action before this, we're actually going to check this value to have it active. So the set active action, again, it's not an action that's defined inside of Behavior Designer. It's actually the method on the game object provided by the Unity engine. And here we are using it. So it's a whole new way to use actions inside of Behavior Designer. And honestly, a very convenient one. So your code will seamlessly integrate with your behavior trees. Okay, let's have a test here. Our character is moving and now his energy is about to deplete. Okay, so he's sleeping with the particle effect playing. And when he gets up, the particle system is disabled. Now again, he's sleeping. Okay, so let's set these values back to some reasonable values. For example, energy consumption rate, let's set it to 5. That way it would take 20 seconds for energy to deplete. And let's right click and apply it to the prefab. And now let's enable the pawn manager and let's run the game. Okay, so let's look at our characters. Now they all have full energy, so they're going to sleep. Since they all start with 100 energy, they will more or less sleep at the same time. Let's look at them here. They're sleeping on the job. So you can see that when they get up, it's nice to have this little pause before they continue what they're doing. Okay, let's go back to our behavior tree. So here our sequence is able to interrupt its lower priority tasks, but we can also set it to interrupt itself. If we do it like this, then everything that comes after this conditional will be interrupted if this conditional changes. So if we have a branch here that's way more complicated than this, and let's say our behavior tree is stuck there while this conditional has changed, then having our sequence like this will interrupt this child branch if the condition has changed. So here we can have the sequence set to either lower priority, self priority, but we can also have the abort type set to both directions. So these abort types are really powerful and will allow you to express a lot of behaviors. But don't worry if you don't get it right away, we will see a lot more examples of this. Okay, so the main takeaway from this episode is that the selector works pretty much like the sequence. the first child that succeeds is going to end the selector, and we can use priority to interrupt lower priority branches and keep checking this conditional even when we're out of this branch, which makes our behavior tree reactive to changes. Alright, that's it for this video. See you in the next one.